So a system, and these first couple of questions are review of last time. A system is more than one equation. And we just did our graphing in the warm-up. We solved by graphing last time. That's where you graph both of them. And then you just write the answer, which is where they intersect. So the solution to the system is a point that satisfies both of the equations. It will be an intersection. So again, that's what we just reviewed in the little relay game warm-up. I'm going to see if you remember the three possibilities. There's three ways that your graph can turn out. So what is one possibility of how it could turn out? One solution, which is how I made all of your warm-up ones turn out. This is one solution. Good job. That's where they just cross you. No solution. What would that look like? Parallel. Good. Perfect. They're not going to intersect. So that's no solution. And you're correct, but I can't even write that fast. So hold on a second. What would infinite solutions look like visually, though? Yeah, like it'll look like just one line. What it is it's actually two lines literally right on top of each other. So they intersect everywhere. So infinite solutions. Good job. You guys remembered from last time. Perfect. That's our review of last time. 1 and 2 are also going to be review questions. I'll probably just do one. We don't really need to do both of them. Let me pull up my Desmos here. Again, the point of notes is for you to understand what's going on. We just need to do enough for you to understand. I'm not trying to torture you. Now, while I'm typing this in, because I know that's boring to just watch your teacher type things, your job is to do what? What did I say you needed to do?
Look for mistakes.
Look for mistakes, which I actually made one last time. So can you look at number 1 on there and watch me type this? And tell me if I make a mistake. Maybe I'll do it on purpose to see if you're paying attention. I don't know. I'll try not to make a mistake there. Does that look right? Okay. Now they almost look parallel, but yeah, they're not. Like it's going to intersect up here. I can zoom out a little bit. So I'm going to click on the intersection. Boom, it's right there. 15, 20. So when I look at my paper, it's a yes or no question. Is it yes or is it no?
Yes.
Yes. 15, 20 is the solution. You would do the exact same thing with number 2. You would type this in, click on the intersection. It's either a yes or a no. Are we all good? You guys all told me it was easy last time, so I think we're okay. Now, this is the new stuff. This is the stuff for today. That was solving by graphing. You just make a graph and look at the intersection. This is called substitution. Even aside from math class, can you shut that for me? Even outside of math class, we should know what the word substitute means. In your own words, if you substitute something, what does that mean? Replace it. You take something out. Please don't do that. I spend my own money on those. You take something out and you replace it with something else. You okay back there? All right. Substitute. So what you do is you solve an equation for one variable. You pick the one that's easiest, substitute it into the other equation, and then you solve. Just like we did on the last test, the one that you guys all did really well on. Okay, so it's going to be just like that. So look at this first one. Do you see a variable that is by itself, X or Y? Do you see one that's alone? Yes, which one? No, there's only one that's alone. Alone, all by itself. Do you see how Y is by itself right here?
Oh, yeah.
Now I'm going to highlight, but you could also just circle it. Do you see how Y equals 3 plus X? If you don't have a highlighter, just circle that.
Yeah.
Now I'm going to substitute 3 plus X in for Y in the other equation. So I'm going to take this and substitute it in there. Do you see how I'm going to remove Y and replace it with 3 plus X? Are you with me here? Now the most important thing when you replace is a hug. You need to give it a hug when you replace. Parentheses are important. So we're going to have X plus, and I'm replacing Y with 3 plus X. Do you see how I did that? I took out Y and I substituted it with 3 plus X. Still good? And then equals 5. And then you just solve like we did last unit. You guys all did really well with it. So just do it again. We have X plus X. If you put those together, like terms, what do you get? 2X. Good. Plus 3 equals 5. And then just keep going. You guys are good at this. What's the next step? Yeah, minus 3. So what is that going to be? 2X equals 2. Good. Almost there. divide by 2, x equals 1. Here's the thing. It has to be an ordered pair, x comma y. So we have x, it's going to be 1 comma something. How do you think we could get y? We have the x is 1. How could we get y? Take 1 and do what with it? Well, 1 equals what? X. So if I plug that in for x, I'll get y. Do you get, like, can you see where I'm pointing here? If x is 1, put it together. But thank you. I didn't want to tell you because I feel like you'll remember better if I don't. Do you see how 3 plus 1 equals 4? If x is 1, 3 plus 1, 4. This is your answer. And if you were to graph it and click on the intersection, your intersection would be 1 comma 4. If you were like, hey, I'm confused, I didn't quite get that, I got you. We're going to do a few more. All right. I'm not going to do just one and then be like, all right, see ya. So look at this one. You have to be a good noticer. Do you see one variable that's alone? Alone. Yeah. Do you see how y is alone? Y equals all of this stuff. I'm going to substitute that in for y in the other equation. Go ahead. Be quiet while I answer his question. Yes, and parentheses are, yes, did you hear that question? Yes, the minus is before it, and we need to give a hug. So it's going to look like this. 2x minus parentheses 2x plus good equals 3. That's really the only new step is the doing the substitution. After that, you're just going to solve, just like you did last unit. What would you need to do here with this negative? Or if you want to think of it like a -1, what would you need to do with that -1? Since there are parentheses. Yeah, and what is the word? It is multiplying, but distribute. Good. We're going to distribute the -1 into there. Distribute. So it'll be 2x. I'm distributing a -1 into those parentheses. So it'll be minus 2x. And then -1 times 1 is -1 equals 3. Go ahead. Stay quiet while I answer her question because you all benefit from it. So that is a really good thing. And I was wondering if anyone would notice. You don't need to distribute a plus sign because it's not going to change anything. But if you wanted to think of distributing a +1 through there, it's the same thing. The reason it's really important here is because it was a negative. So we're distributing a -1. That does change stuff. So you don't really need to distribute a +1 because it's not going to change anything. But you're right. Okay. What do you notice is going to happen here with your like terms? 2x minus 2x. Yeah, they cancel. I got -1 equals 3. Good. So if I graphed these, what would they look like? Parallel. We're going to do one more and I'll give you your halfway break. It feels like we're making progress and you're all staying quiet and paying attention and asking me good questions. So I want to try one more before I lose your attention. I will give you a break, but let's try one more. Do you see a variable that is alone, like completely alone? Do you see how x is alone in this one? You with me here? Sorry, I'm trying to end a pass. Do you see how x is alone? So x equals all of that stuff. You got to catch up. Flip over to the other side. We're on number 3. Just start where I'm at. I'm going to substitute that in for x in the other equation. And if you want to just draw a circle around it, like if you don't have a highlighter, draw a little arrow for yourself. You're going to remove x and replace it with all of that. So it's going to look like this. 3 and then what? Hey, I need for you to deal with that stuff on your own time. Parentheses, good. And then what goes in the parentheses? What am I substituting in? 4y minus 17, just all that stuff, minus y equals 4. Good. You just took out x and replaced it with all of that. After that, it is no different than last unit. You're just going to solve it. Yes, sir. The x is alone right here. X equals all of that. So I took all of that stuff and replaced it in for x in the other equation. It's like I removed this, see it? I removed this x and replaced it with all that stuff. Yeah. Well, we are going to solve for both, but at the end. All right. What do I need to do with this 3, guys? Distribute. Good. From here, we're just solving an equation. So what will that give us here? Can you guys focus? You're going to have to do a classwork on this, right? 4 times 3, 12y minus. Oh, if we don't know 3 times 17, what are we going to do? What is it? 3 times 17? Negative 51. I know, I wrote the negative. I just didn't type it in. Minus y equals 4. I love that you guys were like negative. Like, I know, I just didn't type it. Sorry, I wrote it on the paper. All right, then what? Good. 12y minus y. 11y. Good. Keep it going. Just keep going. Plus 51. I'm going to have to move over here because I wrote too big. 11y equals 55. Good. So y equals 5. Now your answer needs to be something, comma, something. And this is where this is a little tricky. Did we find x or did we find y? We found y. So the 5 goes here. You see what I did? It needs to be x, comma, y. Now, if y is 5, just plug that back in for y and you can get x. Usually I just try to get everybody to do this in their head or use the calculator. If y is 5, can you just watch? You guys are all really smart. Just watch me point to this. You'll be fine. If y is 5, 4 times 5 is 20. Good. Minus 17 is 3. And if you didn't know 4 times 5, type it in the calculator. But if you graphed these, they would intersect at 3, 5. So I'm actually going to do number 5 next. Do you see a variable that is alone, like all by itself? Do you see how y is all by itself? All of this stuff that y equals is going to be substituted in for y in the other equation. It's a replacement. So what are we going to write? 2x, good. Okay, you guys are correct. Now you're saying it faster than I can write it. 2x plus 2 parentheses, and in those parentheses, you're going to put 16. Good. All that stuff. Yeah, there's a lot of 2's in this problem. Now, again, after you do that step, can you write this down with me? Pretty please? You're going to have a classwork on it in a couple of minutes, all right? After you do that, it is no different than what you did last unit. You are simply solving an equation. So what is your next step? Yeah, distribute. Good. So 2x minus 2x. Does anyone know 2 times 16? If not, I'll tell you. I'm just throwing it out. Oh, good. 32. 36 was close. Was 2. Estimation is a good skill to have. And then what happens here? Good. Those cancel. You get 32 equals 2. So no solution. And again, follow-up question. Focus for me, ladies. If you graphed those, what would it look like? Parallel. They would not touch. All right, before we do the word problems, I saved this one for the last one of these because do you see a variable that's alone, like all by itself? No. Well, the x almost is. We're going to have an extra step in this problem where we have to get one of the variables by itself. But do you guys see how the x is the best choice? You need to focus. Focus. All right. Again, you guys outnumber me. I can't come over and say this individually to all 23 of you. I have to be able to say it once and have you all listen. What would I need to do to get this x by itself? No, there's no parentheses, so we're not going to distribute. Good, thank you. We would minus over the 3y. And I'm actually just going to write it like that so I don't have to copy the whole thing all over again. So can you guys all look? I'll point to it and explain it to you if you stay quiet. Look, do you see how x equals, stop talking, thank you. Do you see how x equals 7 minus 3y? Okay, so now we've got x by itself. I'm going to plug all of that in for x in my other equation. But we had an extra step where we had to get x by itself. Sometimes you have to do that. Hold it together. So I'm going to write 4 parentheses, and in those parentheses, look, do you guys see how I'm writing it? Like I'm kind of leaving it blank. 7 minus 3y, good, oh, whoops, copy error. 7 minus 3y gets substituted or replaced into there. Minus 2y, good, equals 0. After that, this is no different than last unit, and you guys all did really well with it, so just do it again. You're just solving an equation now. So now what? Yep, distribute. Good, 28 minus 12y And then basically you're just copying the rest of that. This is good. Focus for me, right? That's not good. Everybody's with me. Nice. All right. And then you're going to put the y's together, like terms. So it'll be 28 minus how much? You've got negative 12 and negative 2. Good. Negative 14y equals 0. Keep going. You have a couple more steps here. Yeah, minus 28. So negative 14y equals negative 28. You would divide by negative 14. Now the negatives are going to cancel, and it is positive 2. Nice job. Now when you go to write your answer, it has to be something, comma, something. Since we found that y is 2, where does that 2 go? Good. It's the second part. It's the y part of the point. And now I usually just encourage everybody to kind of either do this part in the calculator or do it in their head. Can you guys all watch? Just look, just watch. I'm going to point to it and show it to you. If y is 2, what is 3 times 2? Do you see where I'm pointing? 3 times 2 is 6, and 7 minus 6 is 1. So if you graph these, they would intersect at 1, comma 2. Okay, last two are word problems. That means you have to read. Are you ready to read? Can't let this just distract us, okay? Chase received a total score of 1340 on the SAT. Is that good or bad? Hey, stop that. That is really good. Do you know what the SAT is out of? 1,600. Anything above 1,000 is pretty good. So his math score, 400 points less than twice his verbal score. We'll get to that in a second. What was his math score and verbal score? Hold on. I need for you guys to stop that because it's distracting me. First, First, we need variables. I'm going to make math be X and verbal be Y. You have to first do that, like make your variables be in there. Now, if his total score was 1340, that means X plus Y is 1340. Do you get what I'm saying? Like if you add them together, your total was 1340. Are you with me here? All right, now this is the tough part. His math score, which did I make math X or Y? X. This is going to be X equals his math score is 400 less than twice. And hold on. Can you just let me explain it? Stop talking. 400 points less than twice his verbal score. Now, verbal was Y. How would I do twice his verbal score? 2Y. Why would it be minus 400? Because that's 400 less. So we set it up. Good. Do you see a variable that is alone? Which one? X. All of this gets substituted in for X. If you don't have a highlighter and you just want to draw a circle around it and draw an arrow, we're going to remove X, replace it with all of that. So that will give us 2Y minus 400. And then what? Yeah, that, oh, hug, good, thank you, sorry, hug, plus Y equals, yeah, 1,340, 1,340, however you want to say that. Now, I love that you said parentheses. We kind of didn't need them in this case because there's nothing to distribute. We can just go ahead and do the like terms. So if you put your like terms together, what are you going to get? Yeah, 3Y minus 400 equals 1,340. And then, yeah, good. Are you writing this down with me back there? Hello? You're going to have a classwork. You're going to have a quiz. You're going to have a test. This, you have to care now. If you wait until the quiz is in front of you, it's too late. Now is when you have to care. All right, 3Y equals, good. Thank you. I heard you. Trying to get everybody together back there. And then divide by 3. I'm going to put that in the calculator. Let me share my screen here. Hopefully I'm on Desmos. Oh, good. I am. All right, what was it? 1740. Divided by 3. So 580, is that his verbal or his math? Why is it verbal? Verbal is what? Now, if you want the math score, you just take that 580 and plug it back in for Y. So look at where I'm pointing. You would do 2 times 580 and then minus 400. Now I'm going to just type that in the calculator. Can you guys just all look? It would be, yeah, an estimation is a good skill. All right. Hey, what was it? Minus 400? 760. So X equals 760, and that's his math. So did this person do better on math or verbal? Yeah, by like a good bit. but the overall score was still good. All right, let's try one more. This one's about football. That's like your English. Right, because it's a word problem, so it's more important just to put your units. This was math. I guess you could write math score, and this was verbal score, as long as you know which one's which. All right. At the end of this football season, 31 Super Bowl games had been played with the leagues. We have AFC and we have NFC. So I'm going to make AFC be X, NFC is Y. We got one more to get through. Just hold it together. Now, if there's a total of 31 games, put the equation together for me. It's just like this one. We had a total of 1,340 points. If there's a total of 31 games, what's our equation?
31.
Yeah, good. Add them together, you get 31. That's your total. Now you need another equation. The NFC, is that X or Y? How we labeled it? Y. So we're going to have Y equals. The NFC won 5 more games than AFC. So good job. Nice. X plus 5. 5 more than. Do you see a variable that is alone? Y. All of that gets plugged in for Y. See, you guys, like, you get better at it the more examples you do. That's why I don't just do one and say, see you later. Like, you have to do a few. So it's going to be X plus what? X plus 5. And I put the hug around that, but you kind of don't need it in that case because you're adding. I mean, and there's nothing to distribute. All right, equals what? 31. Good. Nearly there. Like terms together. X plus X is 2X. You see, some of you are with me and some of you are like not even writing it down. It's confusing for me. We're going to subtract the 5. So that would be 26. Good. Divide by 2. Does anyone know that one? If not, I'll tell you.
No.
13. Good. Now, was X AFC or NFC? AFC. So 13 AFC, games. I don't know, whatever you want. As long as you know which one's which, I'm happy. And then you're going to take 13 and plug it back in to get Y. X is 13. So 13 plus 5 is 18 NFC games. Good job.